I'm Jan Brejcha, coming from Adobe and also from Brno University of Technology, and I would like to thank other contributors of our paper, who are actually Michal, Lukác, Zhili, Chen, and DiVerdi from Adobe, and also my supervisor from Brno University of Technology, Martin Cadík. And imagine that you have just returned from your wonderful trip to a gorgeous natural location, and you have a bunch of photographs you want to present to your audience. And you also can imagine that this preparation for your presentation will be quite demanding. You will need to prepare the best shots you took, and you also will need to prepare your narrative to it, and then you usually show all the images in a way of a slideshow. So you just show one image followed by the other, and tell your story with respect to these images. You maybe see that something is missing from here, and actually we might miss the location context because users don't know where the images were taken from. And of course you can tell them, and you can also put a map into the presentation. However, we wanted to have something more immersive and more enjoying. So instead of this, we are proposing our new presentation mode. Let me show you a demo here. So basically you see a camera flying through a virtual terrain, and it comes to the first photograph, and you see a transition from the camera to the photograph, and then again back, and the camera follows the path basically the hiker took during his own trip, and this way recreates the original hike. So you can see all the surroundings of the original terrain surrounded in the photographs. Yeah, so this is the overall idea, and let us focus now on the pipeline, how to create this representation. So first of all, we get all images from our user who took them on his hike, and we also need some information about the location where those images were taken from. So they might contain a GPS text, but they don't need to necessarily. We could just use the information of course area the user will provide us, saying like, okay, it was in this mountain range, and we will use this course location area information to download images from Flickr. And we basically augment the initial set of images by these downloaded images from Flickr, and use all these images together with a structure from motion to estimate the 3D scene. So this way we get the sparse point cloud, also with camera positions and orientations and other camera parameters. We have now like relative reconstruction, and we need to align it with the world reference frame. So we use the GPS coming from Flickr images, and also possibly from the images of the user, to align the whole 3D scene with the terrain model. First using the GPS only, which you can see on the first line, but this initial geo-registration is not perfect, and we need to improve it by geometric alignment of the 3D point cloud to the terrain. So we sample the green point cloud on the bottom right image, and basically align the red point cloud to the green one. We obtain the blue, which is aligned to the terrain, and this gives us transformation, which we apply to the cameras, and you can see on the second line that the alignment is improved quite a bit. So we have now aligned our cameras with the terrain, and we use them to generate the fly-through. We can forget all those Flickr images. We don't need them anymore, because we are focusing on recreating the trip made by the user. So we use all the positions of the photographs the user took, which are the yellow dots. And the user also selects the photographs he wants the animation to stop at. And then the camera path is basically recreating by creating a smooth spline with camera positions being those yellow and green dots as control points. So this way we recreate the camera path and we interpolate between camera orientations from the first photograph to the second one and following. And we may export this representation to a passive fly-through, which you saw earlier, or an immersive interactive fly-through, which can be seen in VR. And let me show you an example right now. So the fly-through is very similar to the first one, but the user can also look around in virtual reality and see the space around. We are in Yosemite Valley right now, and these are images taken by my colleague, so we just used our system to recreate his original hike. And the user can also control the speed of the flight between the consecutive photographs. So this way he actually recreates the hike himself. We evaluated several aspects of our new presentation modes. So we were interested in whether our new modes of presentation give spatial context to the user, so the user is able to self-localize himself using this kind of presentation. Also, we were interested whether our new modes are enjoyable and users are going to potentially use them, and whether the users feel more present in the environment while consuming such a presentation. So we compared 4 modes of presentation. The first 2 are baselines. The easiest one is the slideshow, where basically one photograph is followed by the other one. Then the second mode is slideshow with GPS positions. So for each photograph, you see also a top-down view where the position of the photograph is marked on a map. However, you don't see any orientation of the photograph here. The third and fourth modes are passive and interactive fly-throughs. So you basically see the position of the photograph inside the terrain and also the orientation of the camera. We also created 4 datasets for this evaluation. 3 of them contain our own images. These are the Lake Tahoe, the first demo I showed you, the Yosemite dataset, this was the immersive fly-through you already saw, then the Nepal and Tatras datasets. Basically we show the slideshow or one mode of presentation to the user, and then we ask the user to complete another set of photographs. These are completely different from the first set, but are coming from the same hike. So they are somehow similar, but not exactly the same. And a user gets a photograph, and we want him to show the position, which is marked by number 1, and also a reference point, which is marked here as number 2 and a star. And the same reference point we want to also mark in the original image, so that we may evaluate the position error and also the orientation or heading error in this case. We had 21 participants, and these are predominantly bachelor and master students of IT and law. 3 were women and 18 were men. And we report the positional and also the orientation error. The important thing about our study is that it was really difficult to evaluate, because we have 4 different datasets, which are basically 4 different conditions, and all these datasets have very different spatial extents. So, for example, the Nepal dataset is a very large area, and the Lake Tahoe is a very small area, but we need to somehow compare these with respect to each other. So this actually creates some heavy bias, which we needed to mitigate, and we did it by normalizing by the baseline slideshow only. because this is basically the worst scenario the user can have. And we may see that in this case the scales of those errors are nearer to each other, and we may also see that the Nepal and Tatras datasets seems to be more difficult than the other two, which is also expected because Nepal and Tatras are quite large datasets taken in several days. So let's look at the evaluation of the position error, and we may see that there is a significant difference between the baseline slideshow presentation and all the other three modes. So we may conclude that the baseline presentation is not helping users to self-localize much, and the other three modes are somehow comparable to each other, which is good for us, because actually the GPS slideshow is the most similar task to the actual evaluation, and the immersive and passive fly-throughs are like not from the top-down view, but from the terrain, which is also difficult to users to mark on the map. With respect to the orientation, it was really difficult to evaluate because the data coming from the users were very noisy, and it is very difficult for users to estimate the reference points in those images. So we didn't see any significant difference here, but on the easiest Tahoe dataset, we may see that those two new modes, the passive fly-through and VR, are having somehow a smaller orientation error in the mean and also in the median. However, this difference is not significant. With evaluation of the presence and enjoyment, we did that by several questionnaires. The presence was evaluated by the Slater-Usok-Steed questionnaire, and we may see that the immersive fly-through obtained a little bit better score, but also not that much compared to the GPS slideshow, and this is mainly because users were complaining about the quality of the terrain, which is of course an implementation detail for us, but it's very important to users. So in case we had a better model, like probably a Google Earth or something like that, the result should be quite different. Also, with respect to the enjoyment, the users really liked our approach and enjoyed the VR presentation a lot compared to the other modes. There are a couple of shortcomings, of course, coming with our method. So the largest problem here is that the download and the reconstruction of the scene takes quite a lot of time. So possible future work is to extend this approach by some heuristic, which will be able to somehow say or define which locations specifically in the area are more interesting and which are likely to be matched with different images, and so we can mitigate the download time of those images, and also we may improve the representation of the terrain model with using our own reconstructions, because these landmarks can be reconstructed pretty well with a lot of pictures, and we may use this information to back project, for example, the texture into the terrain, so that the terrain looks nicer in these areas of interest. To conclude, we created a pipeline where we are able to reconstruct the original hike taken by the user using only his own photographs. We don't need any special equipment for capturing these photographs. You may use your own camera or cell phone, and you need just to provide a rough area where those images were taken from. We proposed two modes of presentation. the passive mode and the immersive mode in virtual reality. And we also created 4 datasets for evaluation and compared to baselines. And the result is that our method is more enjoyable, immersive, and helps spatial understanding the same as the GPS slideshow. So this is all from my side, and if you have any questions, I'm happy to answer them.
Thank you. Okay, so we have a question there. Go ahead.
Hi, my name is Lisa. I'm from ETH Zurich. Very interesting pipeline. I have one question about your user study. So you looked at the positional and orientation error, and it seemed that those the results were pretty similar on the different conditions that you tested on. Did you also test your participants on spatial orientation sense, so their spatial abilities? Because they might have had an influence on the results as well, right? If someone is better at perceiving orientation and position.
Sure. So we didn't make any spatial orientation experiment. We asked the users a couple of questions, whether they visited the location already, and whether which are basically their experiences with virtual reality and with hiking, and also with navigation in a map. So we have all these questions in the questionnaires, and we tested with statistical tests whether these conditions are actually somehow changing the results, and we didn't see any significant change based on these conditions. But also the truth is that we would need a lot more users to execute better statistics on top of this. Truth is that the experiment took 1 hour itself, so it is quite demanding for the user right now, and it's very difficult to measure more per user.
Thank you. So there's a standardized questionnaire for spatial abilities if you want to look into it. It's the Santa Barbara Spatial Orientation Sense Scale.
Okay, thank you very much.
Go ahead.
Really nice work. Hao-Chi from Northwestern University. I was curious to ask if you think the same approach would apply to doing city scenes, or if you think there might be some challenges in the city that would be different from in this domain.
So right now we are using the digital elevation models to render these scenes, and we don't have digital elevation models for cities, so we need some other kinds of models for them, because the digital elevation model of the city wouldn't look so compelling compared to the natural locations. So if we have those, we might use also this in the city, and there is also previous work which actually did this alignment of the scene to the city location with a slightly different approach. But of course, this method is applicable to cities as well if you have those models.
Thank you.
You're welcome.
Jan?
Hi, Jan Borges from RWTH Aachen University in Germany. I really like the idea of placing these images into context, and it looks like it could give people a sort of more contiguous experience of understanding where everything is. What I'm wondering about is 2 things. First of all, if you show these pictures to other people, one option, of course, is I put them online, somebody else looks at them, in front of their own whatever tablet or laptop, and there's no social interaction other than that person doing that in isolation. And in that case, I can really see how your system would help that person to understand it better, but there's often a social thing going on when I'm showing these pictures to others. What was your study like exactly, and did you look at these 2 different sort of usage scenarios, or was it just users without the actual sort of photographer in the room?
So we were most interested in the position and orientation errors, and whether this actually helps the user to understand the location without any other inputs. So we didn't add any narratives or these things. This should be interesting extension of our work, but we didn't consider that so far.
One of the things I'm wondering is if you have this narrative going on where somebody's showing, this is where I went last year and let me show you my pictures, whether that could maybe even be too distracting from the person-to-person interaction. The other thing, if I had a quick look at the paper, it looks like your study user groups, your participants were bachelor's and master's students in computer science and some law students. There was a great talk at SUI earlier this week on the effects of different age groups, and for this one in particular, I'd be really interested in knowing how this works with people from who are not undergraduates, basically. So I think there might be a pretty serious effect there.
Yeah, I presume that as well. I think that, for example, the VR is not really suited for maybe older people because they somehow adjust a little bit. Their adjustment time is a little bit worse than for the young persons. But also we did those experiments only with those young people because we didn't have any good source of other age groups.
Yeah, and I totally get it. We all have the same problem, but I think we have to be really careful about claiming any external validity if we're studying it with undergrads. So.
Yeah.